In this lab, we will continue with the special analysis um, for the Alpine Faults line based in South Island. First, we make a copy of the building's data frame. So what we are doing is that in this lab, we are finding the nearest geometry in the earthquake region for the Alpine Faults for the buildings located around it. So first we make a copy of the building's the data frame, and so it looks like this. So buildings equal buildings dot copy open and close bracket, and then we print the build data frame, and it looks like this. Then what we will do, we will insert a cell and we will visualize build. So build plot. So this build.plot open and close bracket will display the polygons, these multi-polygons. So we get this. So this is the buildings data. And now we want to find nearest buildings geometry in MMI geometry. Remember the MMI geometry? Now MMI geometry is MMI is the intensity, earthquake intensity, the power of the earthquake, how strong it will be in around the Alpine faults line. So MMI underscore nearest equal to MMI data frame dot so the index we want to put it in series, so we put S index dot nearest, and we put open bracket build dot geometry dot centroid close bracket. Now this is very important that we put the centroid, because we will find the for each of these multi-polygons in the building's geometry, we will find the centroid, and for that centroid we will find the nearest polygons, multi-polygons in MMI. So if we want to we can visualize this centroid. Geometry. So the centroids are plotted here in build dot geometry dot plot. Okay, so these are the geometry multi-polygons, and this is the centroid build.geometry.centroid. Now we find the building's geometry centroid nearest building's geometry, the centroid, in MMI geometry. Okay, so next we check the values of nearest geometry. So what we do is that we uh, use the pandas and pandas data frame, pandas.data frame. This will display the values in the table form. Open bracket, pandas.series. Now it's very important that we convert that to pandas.series form because MMI nearest values are in NumPy form. So MMI underscore nearest, and we will read the one where there will be two arrays produced, and we want to select the second array. The first array will be for this building's geometry and indexes, and they'll be the same, but we want to uh, uh, use the nearest geometry from MMI data frame. So we'll choose the second. And then we do dot value counts, open and close bracket. So we just wait for this to finish processing. It's taking a bit longer. Now we had earlier on already done that, and the values are here. So you can see the indexes of MMI data frame and then the count values. Now we create a new column in build data frame. So build open square bracket and then the new column near underscore IDX equal MMI underscore nearest 1. So you want the second array. So build dot head gives this. So near IDX values are here. Then we reset the index for build. So build dot reset underscore index and bracket drop equal true. So if we don't do drop equal true, there will be a column created for old index. Then we dot join and open bracket MMI square bracket, we join the MMI values, comma, on equal near IDX, this column here. Now this column, near underscore IDX, contains the row names for each of the rows in MMI data frame. So on equal near IDX, comma, how equal left. So this command when we pass, then the builds data frame will be on the left and MMI column will be joined on the right, for which the names near underscore IDX values equal the names of the rows in MMI data frame. So that finished running. Now we can see that there are two rows, and so the second array is this one, and the first array, which is 0, is this one. So this is exactly the same, almost the same values as we'll do unique here. Yeah. So the row names, these are the exactly same as the building's data frame. So the first array, we don't want the first array, we want the second array. That's what. Okay, so let me run this. So we have near IDX and we run this one, and you can see that the column MMI is created. So find the MMI values for chosen near IDX in MMI data frame. So what we're doing over here for the location, for the name 113, we want to see which row in MMI data frame contains the row name 113. So for I in range length of MMI, if MMI dot I location square bracket I close bracket dot name equal 113 close bracket colon display open bracket MMI dot I location open square bracket I close bracket, and that gives the name 113 and MMI is 10. So 113 contains 10, and if we check for 649, then it should be 5. So let's have a look. Yeah, so MMI is 5. Drop the near underscore IDX column, build dot drop near underscore IDX dot comma access equal 1 and comma in place equal true. So that drops the near IDX column. This. Using nearest underscore geoms definition. So this is we done that. So yeah. So this one over here is using the definition. Alright. So let's do it after. Now what we want over here is to look at the visual plot of MMI from buildings data frame. So background map equals South Island dot plot open bracket color equal light gray close bracket build dot plot open bracket AX equal background underscore map comma column equal MMI legend equal true. So that gave bit of error, and the error is MMI. Okay, so let's look at build data frame. Oh, don't have MMI. What happened to MMI? Okay, so we need to run this. New IDX is created. Then we join, but we didn't let, and then we need to add that. So what we'll do is we are just looking at where we created for bridges. So what we will do is that here we want to put so assign this to build equal to join, so that will join the corresponding MMI values. It gives us data because we already run it. Now we need to insert new cell and we print build data frame, and it contains the MMI values. Now we want to check if this is correct. So for name 649 the MMI is 5, and we want to drop the near IDX value, and then it doesn't contain the near IDX, and then we want to visualize. Okay, so it's either we run the nearest geom definition, or we use this long method. So running the definition is quite easy. So columns to keep is MMI, uh, and geom is build.geometry.centroid. And you can see around the Alpine fault there is very high MMI values, the yellow ones, and the dark blue one is the MMI value is 5 and 6, and the greenish bluish green blue combination, that greenish blue is about 7, 8 and 9. So this is how we did that. So build.plot, and we used the axis equal background underscore map, comma column equal MMI, comma legend equal true.